Hello, everyone. Thank you for taking the time to come to this presentation. This is Tell Me Again, Why Aren't Your Engineers Using Cost Insight? My name is Abe Chavez, and I am a principal consultant here at aPriori. Um, Before we begin, I just want to have just a few housekeeping notes. So all the attendee lines are going to be muted throughout the session. We are going to be taking questions though, but the questions will be utilizing the chat panel that is on the event website, not on the Zoom chat. So we will be monitoring the chat panel on the event website at costinsight.com. You can also feel free to schedule a meeting with me via the scheduler that is on the event website. And, just click on my name and you can set up a meeting with me for later on. And also, we have uploaded a PDF of this presentation to the same event website, and you can download it from there. Okay, so my goal is to show you why really aPriori should be in every engineer's toolbox, really. And I'm going to do that by showing you a couple of real practical step-by-step examples. Okay. But I want to begin by asking a rhetorical question. So what if your engineers had insight into how much it would cost to make the part they have on their screen at the time that they are designing, right? I mean, all of the people who are familiar with aPriori know that this is what aPriori does, but what if you could get more than that? What if they could be shown where most of that cost is attributed to, right? Is it all going into material? Is it going into machining? And if within machining, what portion of machining, right? Is it grinding, as we're going to see in an example later on? And then what if they were shown what features are difficult to make and may cause, right, potential quality issues? And if they were alerted to what manufacturing thresholds are being crossed that forced the manufacturing to be more expensive. So, for example, let's say you have a sheet metal part and you have a certain tolerance. What if you were told, hey, you tolerance this hole to plus or minus half a thousandths, but if you had tolerance it to plus or minus 1,000, you wouldn't need machining. So machining would be removed if you did that. What if the engineer could be told that on the spot, basically, right? And on top of that, what if they could be shown what potential DFM issues are present on the part that they are designing? And they could do that in a minute or two from their CAD model as they are designing, so they don't even have to break step, right? So that's what aPriori can do for you. And that's what I hope to show you today. Okay. So let's start with a little bit about me. Those of you who know me know that I typically talk about sourcing, and you know that I spent quite a bit of time in direct sourcing, and I was actually a sales manager at a 5-axis machine shop. So I've been on both sides of the aisle, buying and selling. But what you may not know is that I actually started my life as an engineer. My first 6 or 7 years of my career at GE Power Systems, I had various engineering roles in steam and gas turbine engineering and auxiliary systems. So I've been there. I tell people I used to work for a living. And so I have a real sense as to why engineers should use aPriori, because I know that it would have been a tool that I would have valued at the time, right? So I know that, when we are designing, right, we have to balance a lot of things. So we start our design and we have to meet certain technical requirements, and sometimes we have some weight restrictions and some size restrictions. And obviously we have to meet a certain amount of quality. Maybe we have to do life analysis. And we're doing that all against time. We're doing that all against the clock, right? And then we keep doing that and reiterating and balancing until we finally decide that the design is good enough to be released, or we got enough confidence that the design is good enough to be released. And then we document we release it, we document our design, right? But nowadays, a new item has been thrown into the balance, and that is cost. A lot of companies are either asking the engineers to meet our cost target, or just asking the engineer to pay more attention to cost. And it's not something that we've been ignoring as engineers. It's just that the feedback on what something is going to cost and what the impact of each design decision that we make has on cost uh, is very slow coming. So we either get it from the suppliers, or we get it from a manufacturing engineer or a manufacturing review, and those don't come that often. And we are always working against the clock. And so not everything gets reviewed, and not every design decision gets evaluated. And so our hope and what we have seen is that actually aPriori has been helping companies reduce the time it takes to gain the confidence to release the design, especially now that you have to keep cost in mind and and quality. Basically, we give you some quality feedback as well as cost feedback. So, when I first started in engineering, it was the mid 80s. And I remember that I walked into GE Power Systems, and obviously we had designers that were working on the board still. Only two of those designers were using wireframe CAD at that time, right? I was one of the first engineers to be trained in ANSYS, and I was given one a fancy color terminal at Tektronix. I remember it was special, one of the special kids that came in and got trained in ANSYS right away, basically. And as CAD and FEA took root, you could see that the time that it took to release a design came down, because you didn't have to do as much testing anymore, right? You could see if mating parts could fit, without waiting until those final reviews and have to reiterate in some of those designs. So it basically it brought the time down, and that's what aPriori is going to do, and that's what aPriori is doing for some of our customers that are already using it, right? Because we can provide you with some cost information earlier, and you can make some of those decisions earlier without having to wait for a supplier to give you a cost estimate. Sometimes you have to wait a week or two to do that, for example. And we give you some DFM feedback on the spot, so that when you get to your manufacturing reviews, there is a lot less issues to work out, right? And so the timeline is actually constricting, and that's one of the most powerful reasons as to why aPriori needs to be in every engineer's toolbox, right? But how do we do that, right? And how do we give you this cost information, right? So aPriori obviously helps the engineer not guess or estimate at a cost, but actually know, when something is driving the cost up, or when something is driving the cost down. And the way that we do that is as follows. I'm going to start from the very top for those of you who are prospects. And so those of you who are customers and know how aPriori works, please be patient with me. It's only one slide, and I just want to make sure that everybody starts from the same point. All right, so this is how aPriori works, right? aPriori basically takes a CAD model and extracts all the information it possibly can from that CAD model automatically, in mostly geometry, right? So if you have a casting, for example, it's going to figure out how big is that casting, what's the smallest enclosing box, how thick is it, how is the thickness varying, how much mass does it take. So not just the weight of the part, but how much mass does it take to actually make the casting? So wasted mass and used and finished mass, right? Does it have any holes? Where are the holes? How big are the holes? Are they round? How does it have any voids, any cavities that it needs to core? All of those things, right? It takes all of those things automatically right out of the CAD model. And then it uses a little bit of information from the user, like how many you're making. Are you making 200 a year, or are you making 2,000 a year, or 20,000 a year, right? It's gonna matter when it comes to figuring out how to make the part. What material is this casting? Is that an aluminum casting? Is it a steel casting? If you put that in the CAD, by the way, they'll pick it up automatically. But if you don't, you need to tell it. So there'll be a few things that the user has to tell aPriori. But once he has that information, then aPriori basically runs through a manufacturing simulation. And it figures out how he needs to make this part, all the machines that he has to use, the cycle times on each machine. So how long does he need to spend on each machine? Like I said, how much mass is it going to consume, not just the weight of the part. And it does that because it has a very rich set of manufacturing rules already pre-programmed in it. So it's going to do things like it's going to look at that hole and it's going to say, that hole is pretty close to that edge. I don't think that is safe to cast. So I'm going to machine it. So I'm going to machine all those 4 holes there. And it's going to add machining automatically to the routing here, right? And it's going to take a look at this holes over here. It's going to say, those holes, they're not close to the edge, but they're pretty small. And I don't think I can cast them. So I'm going to machine them also. So now it adds a second setup to the machining because you have to set a part up this way to make this holes and set the part up this way to make, this holes here. So now we add a cycle time to the machining portion of it, right? So not just cycle time to make the holes, but to set the part up again. And so on, right? So it figures out how is it going to make the part, what machines, how long on each machine, and then it takes that manufacturing information and translates it to cost via what we call the digital factories, which is the data repository where all these rules reside, where all the machines that it has available to make the part reside, all the information about those machines, the capabilities, the sizes, the speeds, and more importantly, the cost. So based on where that factory is, whether it's China or Mexico or India or the US or Europe, it's going to figure out, okay, how long does it cost me to run that casting line? How much does it cost me to run that machine center, right? How much do I pay per pound for the material? And it's going to translate that manufacturing information into cost information. And so what it comes out with is a very rich set of both manufacturing data and cost data, and is in the way that we communicate that data to the engineers that we help them essentially both design for manufacturing and design for cost. And here's how we start, right? aPriori starts by providing you with a summary of the cost. So the very first thing you see is a top level summary of cost. How much of the cost is material, how much is labor, how much is overhead. And then if you have any capital investments at the bottom here, this is a machine part. So your only investments are the programming and maybe some fixtures, right? But here on this side, we see a casting, right? And what you're seeing here are 2 different interfaces. And I wanted to point this out because this is our web interface, which is where most of this presentation is going to be centered around. But we do have our traditional, aPriori professional interface. And you can see that it provides basically the same type of information. So for example, for this casting here, you would have, how much is material, how much is labor overhead, and then you see a much bigger capital investment down here, right? And what we tell the engineers is this summary information is extremely useful. You start with this because what you do is you figure out whether most of the cost is going into material, in which case you have to explore ways to see how you can reduce the amount of material or the type of material that you're using so that you reduce this cost, or is it going into making the part, right? So very first split in the road is, where's my cost going? Is it going to material? Is it going to making the part? And then in this case, for example, most of the cost is going into making the part, which is this variable cost here, right? And so you go from there. So you essentially, you can explore more details on the make cost of the part you can explore the details of what is making the cost of making that part by basically going one level deeper into a priori. And here you can see, for example, that the cost of the variable cost of this casting, which is what the engineer can affect, is about $560, but $470 of that is in machining, right? So it doesn't behoove you to even worry about the casting portion of it. Don't worry about the casting portion of it. Let's focus on machining. And then you can see that of that 470, 450 of it is in grinding. So now you as an engineer, start getting a hint that, hey, maybe my surface roughnesses, maybe they're too tight. Maybe I kept them tight in some of the surfaces that didn't need to be that tight. Maybe I need to go back and take a look at what is driving this grinding and see if I can loosen up some of those surface roughnesses, right? So this is the way that aPriori begins to guide the engineer down the path of what do I need to do? What do I need to do to lower the cost of this part, right? So that's the process we're going to follow to show engineers how to use aPriori to both reduce the cost of the part, and as you're going to see through the examples, how to improve the quality characteristics of the part, okay? So what can you affect as an engineer? The things that you can affect as an engineer mostly are the direct cost, all right? And what goes into direct cost? Where is the material cost? And you can certainly affect the type of material that you're using. You can sometimes have the ability to affect whether you're using a standard size or not a standard size stock. And obviously you can affect the amount of material that you're using or the amount of material that you're wasting, right? So we're going to take a look as to how this can be, how can we impact material cost in one of the examples later on. But you can also affect the cost of making the part, right? So as you're designing, you're affecting the cycle time that it takes to make that part, right? The number of times that you need to set up this part, believe it or not, that is affected by the design. So if we take this part here on the side, and we assume this is a machine part, and for the moment, let's assume that this hole goes all the way through, as it probably does. So if I'm making this part, I could probably make it on a 3-axis machine with 3 setups, right? One from the top, one from the bottom, and then one from that side over here, and make that hole all the way through. So that's how I would be making this part. But now let's say that you needed to add another hole. Let's say that you have to have access for a thermocouple or something in here. And as an engineer, I put a little hole over here on the top. Well, now you can see the cost. aPriori is going to tell you that cost went up, and not in an insignificant manner. Maybe not hugely, but it's going to, in a moderate way, right? Because now it needs to set up that part a 4th time. So it's not just the cycle time of making the hole. Now you have to unclamp it, reclamp it again, right? And then drill the hole. In fact, drilling the hole is probably the least amount of time because you have to reset the part, basically, right? While if you put the hole on this side here, yes, the cycle time will go up a little and the cost will go up a little, but it'll be a small amount because I already have a setup to make this hole here on that side. And therefore, it doesn't cost me all that much more to put the access hole on this side here, right? So that's the type of guidance that you're going to get as you are designing, right? So obviously, there are things that are going to drive, you can make this part so complex that you drive it to a 5-axis machine, for example, and things like that, okay? And you can also affect the tooling cost, but we're not going to talk about tooling costs in this presentation. It's just not long enough. We're going to do 2 examples, a sheet metal part and a machine part. So let's get going here. We're going to start with a sheet metal part. And what we're going to use is this bracket. Now, those of you who have been with aPriori will recognize this bracket. We call it bracket basic. Was our first demo part, and so. But let's just use it as an example now. Let's revive it and use it as an example now. The way that this bracket is designed currently is out of common steel, it's common carbon steel, but it's 6 millimeters thick. So it's a pretty thick bracket right now. And the reason that it's thick is because the amount of weight that it needs to hold here is significant. And we don't want that rate. We don't want this corner here to open. Okay, so we made it very thick. The problem with that is that it also became very expensive. And so now we are trying to take cost out of this part. And right away, we can see through aPriori that most of this cost is in the material, right? So this purple bar is material. We can see that the full cost of this part is $15.30. And out of that, $11.90, almost $12 is going into material, right? We can also notice how the part is made. Right now it's being made in a Tura press, right, to make the cuts, and then the bend brake to make the bends, obviously. But it also has machining, and kind of wondering why the heck it has machining, because we didn't tolerance anything tightly. We didn't tolerance anything beyond reason. So we're going to find out why in a few slides here. And finally, we also notice that this bracket has quite a few DFM issues. It has a high DFM risk here, 23 issues and 1 warning, which is something that we don't think can be really made reliably. Okay, so let's take a look at that. All right. So when we explore the DFM issues, we can see that we do have one failed GCD. It's this one band here, and when we look at that band, we see that the system is basically telling us that this lip over here, right? So it says band flap too small. This lip over here it's too small to be made reliably on a bend brake. aPriori saying that it would require at least a 23 millimeter length of that flap to be made reliably, and now is about 21 millimeters. And you may think that's close enough, but you may have some quality issues, some consistency in the way you manufacture that part if you leave it at 21. And that's something we're going to keep in the back of our mind, because there might be an easy fix, okay? But then you can see here even a bigger number of issues, and some of them which might cause you even more pain, believe it or not, is this distance issues, right? So you see that all of these holes, those 2 holes are too close to that band, so those holes are likely to deform. So if you're going to put a screw through there, sometimes it'll fit, sometimes it won't, depending on how the hole deformed. Those 2 square holes here are too close to those bands, which means that they could deform as well, and you could have some issues there. And obviously those holes there are too close to this slight band here, and they might be even too close to each other. So these issues, they may not be critical. You can still make the part, but it may cost you some pains later on, right? So let's keep on exploring, because we still haven't found out why is there machining on this part. Okay, so we keep exploring the DFM issues, and we see that we had a whole issue here where we had 2 diameter issues. And the issue here is that these holes are too small to be perforated by the Tura press. So what aPriori is saying is the pin that you would have to use would be so small that it would break when it's trying to pierce that thick of a metal. Okay, and so you would break pins, again, you will have serious quality issues. And so what aPriori did is essentially added machining to them. So you can see here, you have to machine these GCDs, and it's going to give you the cycle time that it's taken to machine. And you can explore a little farther. And if you click on process here, you will get this bar chart. And then if you click on machining, you see those are the 2 holes that are machined. And you can see that 24% of the make cost, 24% of the manufacturing time is essentially going to machining, because you have to set up the part, right? It's not necessarily the time to actually drill the holes. It's the time to take the part, move it to a machine center, clamp it, and so on. And it's just guidance that you get right away with aPriori, okay? But let's remember, let's go back to the principles. Material cost was the main cost driver, and so we're going to, our first priority is to attack material cost, and so that's what we're going to do. And we're going to try a couple of things. So the first thing we're going to try is we're going to change material. And we're going to change material to a more expensive material that is stronger. So we found this material in the database, in the aPriori database, which is typically the materials that you carry, okay? That cost about 10% more, but it's almost twice as strong. So twice as strong, only 10% more. I think I can reduce the thickness from 6 millimeters to 4 millimeters, which is by a third. And that should get me a pretty good reduction in material cost. And because the material is twice as strong, I think I might be able to pass FEA, right? So the beauty about this is that you can try these options, see whether they are worthwhile or not, whether they're actually going to drive savings or not, and then do the FEA, right? So save your time. Okay, so let's see how that worked. But before I do that, I want you to guesstimate here, right? Do you think that the material costs, based on the decision that we made to reduce it to 4 millimeters, decreased a lot, a little, or not very much? All right. Do you think that just by doing that, do you think that the DFM issues were alleviated greatly, just a little, or not very much, maybe not even at all? And then I want you to guesstimate the savings that we are going to experience by driving the thickness down to 4 millimeters and driving the cost of material up by 10% or so. Is that 1 to 10%, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. So jot that down or make a mental note as to what your guesstimates are, and let's see the results. All right. So you can see that the cost was actually reduced by 23%, which is actually pretty good. Our material cost is still the biggest portion, obviously, but you came down to $8.61 from nearly $12. And in fact, the piece part cost is now $11.66. And that's less than just our material cost used to be, right? We can also see that the DFM issues are now low. So we still have some, but they're low. And also we can see that we still have that 3-axis machining here. And so we're going to see, try to explore what's going on here, right? So we can see that, yes, that machining is still those 2 holes, all right? So it's the same issue. And when we explore a little more, we can see that although now our suggested threshold has come down, it used to be about 9 millimeters, has come down to 8 because obviously you got a thinner material here, and the pen, it would take a smaller pen wouldn't break, right? It's still, you can't still have the pin be 7 millimeters or 7.3 millimeters. A 7.3 millimeter pin would still break, okay? And you have your threshold for your holes. So now you have a choice to make. If you're going to keep this design, it might behoove you to increase the size of those holes just a little bit so that you don't have that quality issue, and so that you don't have that machining cycle time, which in this case, it's not as big as before, but it's still some process time. So we now see that we still have that machining issue, but the threshold has been lower for the size of the hole, right? So when this material was 6 millimeters thick, aPriori was saying that you needed a hole of at least 9 millimeters in diameter before the pin wouldn't break. While now it's saying you only need an 8 millimeter diameter hole before the pin breaks, right? So still a little bigger than your 7.3 millimeter hole, but it's not as much. So if this is the option that you're going to keep in the long run, you may want to consider, Mr. Engineer, moving this or increasing the diameter of these two holes so that you don't need the machining, right? So that's what aPriori is basically telling the engineer. Okay, let's see what the results were from the questions that I asked you before. So in summary, right, the material costs went down a lot. The DFM issues were alleviated greatly, and our costs went down by 23%. Right, but I still have one more trick up my sleeve. I can actually try to put gussets on that band, and what I'm going to do is I'm going to say, okay, I'm going to go back to my soft steel, to my, regular carbon steel here. I am going to leave it at 4 millimeters. So essentially, if you're starting from the original bracket, I'm going to reduce it from 6 millimeters to 4 millimeters. I'm going to reduce the thickness from 6 millimeters to 4 millimeters. I'm going to add the gussets, but I'm going to leave it at the 1020 steel. Okay. So now, what do you think the impact is? Do you think that the material costs will come down a lot, a little, or not at all? Do you think the DFM issues will be alleviated greatly, a little, or not at all? And what do you think the impact on the cost is going to be by just simply adding the gussets and taking that thickness down from 6 millimeters to 4 millimeters? So from the original design, do you think that cost difference will be 1 to 10%, 11 to 20, 21 to 30, 41 to 40, or 41 to 50? Let you take a mental note of that, and let's look at the results. You can see that this results got even better, right? Like a 36% reduction in cost. Now our material cost is down to 728, because although it's 4 millimeters, I'm not paying the extra 10% for the material, for the more expensive material, right? The total cost came down to 974. And even better yet, look at that. I don't need machining. I don't need machining, right? And why do you think we don't need machining anymore? Right? We don't need machining anymore because this material is softer. And even though I didn't change the diameter of the hole, I still 7.33 millimeter hole. aPriori now knows that, heck, I can actually put a pin through there and not break it, because is a softer material, basically. So aPriori's guidance is good even into that level of detail, and the engineer doesn't have to know any of this ahead of time. It is just guiding the engineer as they are making these design changes, like I said, on the fly, right? So this option decreased our material cost a lot, alleviated our DFM issues greatly, and our savings were essentially 36%, right? And we can put this all in what we call a cost compare, so we can see all three scenarios here, and we can see that this scenario, it was started at $15.30, moved to $11.67, which was actually pretty good, and ended up at $9.74 if we use the gussets. I just want to give you a little caveat here. You can see this yellow triangle here is that it's a warning. So here you have the warning because of that bend. Here you have the warning because of the gussets, and the gussets can be made on a bend break, and but aPriori basically is going to give you a warning and say that's not a standard bend break tool, right? So it is warning you that yes, it can be made that way. It's not going to fail it, but it is not a standard tool, and so your supplier may have to buy a standard tool for that. Those are not that expensive though. So let's move to the machine part. All right, so on the machine part, we're gonna again take it from the top, and we are going to first notice when we cost this machine part that most of the cost is in making the part this time. Yes, material is not an insignificant portion, but the bulk of the cost here is in machining the part. And so the first thing that we're going to do, right, the cost is in making the part, basically, right? And you can see that if I add up all of this portion of the variable cost, that's much more than the material cost itself. And you can see it graphically over here as well. And we can explore those details by clicking on the details of the process here. And you can see, again, how much is material cost, how much is the banso, and most of the cost is in machining, obviously, right? So, Dave is a machine part, right? So we're going to now explore a little more, and we want to find out what's driving the cost of machining to be so high, right? And we look here at the DFM issues, and we see that it's had a medium risk, and it has 34 issues, 34 guideline issues. That's a lot. And when we dig a little deeper, we can see that 24 of them are machining issues, and then we have 10 slow operations, which obviously drive cycle time up. But of the 24 issues, 22 of them are what we call an L over D issue. And so that's the highest number of issues we have. So we're going to explore that first. And so if I click on that, I can do several things. I can click on investigation, and it's going to give me a description of what the heck do I mean by L over D issue. And you'll quickly find out that L over D just means the length of the tool divided by the diameter of the tool, right? It's too thin, right? So that's too high. And so all of these walls are made with a tool that has an L over D ratio that is so high that I have to slow it down, because it's going to chatter at the bottom here. And if I want to keep that surface smooth, or even hold tolerances, I am going to have to slow this down to a crawl. And aPriori gives you that guidance, right? It says the magic number based on the part you're making and the material you're machining is 8. So, and you exceeded that 8 magic number where I wouldn't have to slow down, basically, okay? So the engineer gets guidance right away. Hey, this is where all your issues are. These are all the walls that are being affected by it. This is what the issue is. And here is the threshold that you crossed. And so now, can you do something about this, right? Can you make these corners here a little bigger, right? More radius here, so I can get a bigger diameter tool in there and speed up the machining of those walls, right? So that's the kind of guidance that they're getting. So now let's look at the slow operations, because those also are costing us cycle time. Now, when I click on some of those, right, I can clearly see very quickly which ones are the surfaces that are being machine slowed. And I can see this as this curved surfaces here. And, that's because I can't just mill these faces. I have to go in there with a ball mill, with a point mill. The tool is only touching the surface at one point. And so it's taking a long time in machining these little areas here. However, yes, relatively speaking to other things that are being machined, this is going slow. But when I look at it in total, right, aPriori is telling me that all of these amount to about 1.5% of the cycle time, right? So if I attack this, I may or may not be able to figure out how to alleviate that, number one. And number two, right, it's probably not worth my time. What am I going to do? Maybe bring this down to 1% instead of 1.5%, right? I'm trying to affect the cost significantly without slowing my design time down. And aPriori is giving you the feedback that the engineer needs to say, don't worry about this, right? Yes, it is a slow operation. Yes, it's costing you money, but it's not where the bulk of your cost is. So don't worry about this. Go worry about the L over D issues. And so that's what we did. And we increased the diameter of that corner here and this diameters here. Some of them we couldn't do anything about, right? So maybe we had some design constraints, a mating piece or something. We needed to keep that corner the way it was. And so some of them, that's real life engineering. You won't be able to do anything about them. But we alleviated the ones that we could, and we can see that very quickly we could eliminate most of those issues, 20 of the 22 issues there. But just by fixing some of that, we eliminated some of this contour mill So we eliminated two of these slow machining operations, and we brought the cost down by essentially from 393 to 344. So we brought the cost down by $50, so $49 basically, right? So more than 10%. Not a bad day's work. Not a bad day's work. All right. So I hope that today I have shown you, how a priori can help an engineer A, reduce the risk of having manufacturing quality issues, how to reduce the average cost of the parts that they are designing. Hopefully I have shown you how a priori can help reduce the time it takes to release a design. And hopefully I have shown you how smooth the process is so that it can do it, without even breaking stride while they are designing right from their CAD system. So I encourage you to learn more about Cost Insight design and how that can become a part of your engineer's toolbox. Thank you very much. And just in conclusion, obviously, I want to thank you for attending the class. And I want to encourage you, if you are an aPriori customer, to please write a review about aPriori in some of the software review sites like G2 or Capterra or Trust Radius. So we would really, really appreciate that. Again, thank you very much and have a great rest of your day.